We're talking about the imaginary unit. Imaginary means has an I in it. All right, we're going to talk about complex numbers today. Complex number is made up of a real number and an imaginary one. It's stuck together. You are going to be told in all of your directions to do everything in standard form. Tonight, if you want to work on your web assign, and then tomorrow in class, work on inputting it. So if you have questions, if we can troubleshoot, you're more than welcome to do that. But the standard form of a complex number is like this: A plus BI. Part of the number is real and part of the number is imaginary. So if you're looking at something like this, the real part always comes first. The imaginary part is always second. If it's not written in standard form, points are going to be taken off. How can you tell the difference between the real part and the imaginary part? The one has an I next to it. Very good. All right, the imaginary part has an I with it. The real part does not. Does everybody understand that? Okay. That's kind of what I just said right there. All right, so you have a complex number. A complex number is made of real and the imaginary. That's where this complex comes from. It'll have two parts to it, the real part and the imaginary part. Makes a complex number. You can write all numbers as complex numbers. Any real number like 17 is the same thing as saying 17 plus 0i. You can write any imaginary as a complex number. You can say 0 plus 5i, right? So if you were asked in the first one, 17 plus 0i, what's the real part? 17. What's the imaginary part? 0. So if there isn't something, it's just assumed to be a 0. All right, let's go through some operations here. On your test, you guys are going to have to add, subtract, multiply, and subsequently divide, along with using your quadratic formula. So in a question like this, guys, this is super basic. This is just like combining like terms, like if something had x's and something had y's. Real stuff stays with real, imaginary stays with imaginary. So the first thing you do is identify what's going on between these two parentheses. What are we doing? You're adding. So keep the real with the real. What's 3 plus 2? 5. And then imaginary with imaginary. Sign in front of the term stays with it. So -1 plus 3 is, so it'd be plus 2i. And again, the real part goes first. If you write that 2i plus 5, you're going to get points off. The real part is 5. The imaginary part is the 2i. How's B a little bit different? Right? It's subtraction. This -1, what do we have to do with it? You've got to distribute. Some of you forgot to do that on your long division. Messed up the last part of it. But you can either do your changing of the signs, your distribution within the problem, or you can rewrite it if you want. 1 plus 2i minus 4 minus 2i. So keep real with real. What's 1 plus -4? -3. What's a -2i and a positive 2i? They cancel. You could write plus 0i if you wanted to, just get in the habit. Or you could just leave it as -3. That's fine. I'm not sure how WebAssign takes. I'll have to look at it later. So again, if you want to do the work tonight and then just input tomorrow so we can troubleshoot, that's fine. But again, look at something like C. There's this -1 here, right? So you have 3, distribute that negative. Negative and negative gives me plus 2 minus 3i. Then I just have minus 5 plus i. So real with real. What's 3 plus 2? Minus 5. Okay, cancels out. And then what's a -3i and a positive 1? -2i. So you could say 0 minus 2i, or you could just say -2i. Doesn't matter. But understand that it's negative. If they ask you what the real part is, you would say 0. Here, again, we have to distribute this -1. So it's 3 plus 2i plus 4 minus I minus 7 minus I. Real with real, guys. 3 plus 4 minus 7. Cancels, okay. What's 2i minus 1i? 2i minus 1i. I minus I is? Everything cancels. It's 0. It's okay. So this could also be written as 0 plus 0i, right? If they asked you for that. But it's just 0, no big deal. All right, if we go ahead to perform multiplication, this is a thing that you have got to remember. If I said to you guys, what is the square root of -1? You would tell me it's what? I. Okay? Does everybody agree with me? So if I said to you, I have that statement, which is true, correct? Well, what happens if I square the left-hand side? Okay? When you square a square root, it cancels out. What you do to one side of the equation, you do where? To the other. So that's where we get the statement I squared equals -1. When you guys are simplifying, when you're multiplying and dividing, you should never have an I squared in your answer. What will happen is when you multiply, you might end up with like -3i squared. Well, think about it. What does I squared equal? -1. So this is really saying -3 times -1, which does what? It becomes positive. Whatever the sign is with the term that has the I squared, it's going to become the opposite. So when we talk about multiplying, this is just like we would distributing with a polynomial. 5 times -2 is -10, right? And then 5 times 3i is plus 15i. Can I combine those two at all? No. Is this written in standard form? Yes. Okay, you're good to go then. What's the real part? -10. What's the imaginary part? 15. Okay, good. All right, so now we're going to FOIL. Same thing. 2 times 4 is 8. 2 times 3i plus 6i. -1 times 4. -4i. -1 times 3i. -3i squared. What happens, guys, as soon as you see I squared? You cross it off and then change the sign in front. -3i squared is the same thing as +3. So now you can combine real with real is what? 11. And then what's 6i minus 4i? Plus 2i. Yep. I squareds will cancel out. They become -1. What do you guys notice about C? It's the same thing, but what? What's different? The signs are different. These are called complex conjugates. We're going to need that in just a second. Complex conjugates. Same terms. A and B are the same numbers, just the signs are different. So when I FOIL this, what's 3 times 3? 9. What's 3 times -2i? -6i. What's 2i times 3? Plus 6i. What's 2i times -2i? -4i squared. As soon as you see the I squared, cross off the I squared, change the sign. So now real with real. What's 9 plus 4? 13. What happens with -6i and +6i? They cancel. Whenever you multiply complex conjugates together, your i's will cancel. You'll only be left with just a real part of the number. So D's written backwards. That's okay. It doesn't change anything. I still distribute. So 4i times -1 is -4i. 4i times 5i is plus 20i squared. I see I squared. What do? Cross it off. Change the sign. Is that written in standard form? No. Your answer is -20 minus 4i. People always ask, can I factor that? Guys, we're not factoring or solving. You're not taking out a common factor. Just leave it. How is E different from C? Same signs. Should, when you multiply, because I'm going to write 3 plus 2i times 3 plus 2i, should my i's cancel out? No. But when you FOIL, 3 times 3 is 9. 3 times 2i is plus 6i. 2i times 3 is plus 6i. And 2i times 2i is plus 4i squared. What do you do with the I squared, guys? Cross it off, change the sign. So real with real, what's 9 minus 4? And 6i and 6i is? There you go. Good, 12i. Do we remember this from LQ2? Okay, good. Woo! All right, moving along. I just explained this to you guys. Complex conjugates. It's when a pair of complex numbers, a plus bi, a minus bi, are multiplied together. If you notice, it starts off like this, but then it ends up with just the real stuff. We have to use complex conjugates when we're dividing. If you're given a question, it says multiply each by its complex conjugate. What's the opposite? What's the complex conjugate of 1 plus I? 1 minus I. So when we FOIL this, 1 times 1 is 1. 1 times negative I is negative I times 1 is plus I. And I times negative I is negative I squared, right? Well, when I see I squared, I cross it off. And I change what? The sign here? What number is there? There's 1. So what happens with the i's in the middle? They cancel, and your answer here is just 2. So the complex conjugate of 4 minus 3i is what? 4 plus 3i. So when we FOIL, 4 times 4 is 16. 4 times 3i is 12i. Negative 3i and 4 is minus 12i. Negative 3i and 3i is minus 9, what? I squared. As soon as you guys see that I squared, what do we do? Cross it off, change the sign. So real with real, 16 plus 9 equals 25. And what happens with my 12 i's? 12 i's. Now, the reason we do that, is this okay in math? No. Is this okay with math? No. We don't like radicals in the denominator, right? We have to rationalize. Is this okay in math? No. Cannot have i's in your denominator. It's okay in the numerator, but not in the denominator. So when you get a problem where you have to divide, 6 plus 5i divided by negative 2 minus 3i. First of all, this is a division problem. Why? Because we're dividing. How do you know you're dividing? Because it's a fraction, right? Okay. Now, can you just start canceling like, oh, well, 6 here cancels here. Can you do that? No. Some of you like to create your own math and do that. Don't do that, guys. Right? 6 plus 5i is a complex number in of itself. Negative 2 minus 3i is a complex number in and of itself. In order to get the i's to cancel out, you need to multiply the denominator by its complex conjugate. What is the complex conjugate of negative 2 minus 3i? Negative 2 plus 3i. The only sign that changes is the one in the middle. And what you do to the bottom, you have to do where? To the top. So all you're doing, once you identify what the complex conjugate is, all you're doing is 2 multiplication problems. Let's multiply the denominator first. What is negative 2 times negative 2? 4. What's negative 2 times 3i? Minus 6i. What's negative 3i and a negative 2? Plus 6i. What's negative 3i and a positive 3i? Negative 9i squared. As soon as you see that squared, you do what? You cross it off and change the sign. So this becomes 4 plus 9, which is 13. Do you see the whole reason we did that is so the i's do what? Cancel out. What's negative 6i and a positive 6i? They cancel out. So now you have removed the imaginaries from the denominator. So let's multiply the numerator. What is 6 times negative 2? Negative 12. 6 times 3i plus 18i. 5i and negative 2. Negative 10i, good. 5i and 3i. Plus 15, good, Rendell. I squared. What happens with the I squared? Cross it off, change the sign. So now real with real. What's a negative 12 and a negative 15? Negative 27. What's 18i minus 10i? 8i. Are you allowed to have imaginaries in a numerator? Absolutely. Can you have it in the denominator? No. Now, guys, just say, okay, this is your final answer. But hypothetically speaking, all right, we're going to hypo-speak over here. I came out with negative 27 plus 9i over 12. Hypothetical situation. Does anybody notice anything about 27, 9, and 12? What? They're all divisible. If I were you, I would write this just like you would a quadratic. When you have something plus minus, I would say negative 27 over 12 plus 9i over 12 and simplify independently. What number goes into 27 and 12? 3. So this would become negative 9 over 4 plus, what about over here? 3 again. So this becomes 3i over 4. If they have the same denominator, you can write them over the same denominator. Sometimes it simplifies where one denominator is a 4, the other one's a 2, something like that. But if something simplifies, you have to simplify. In the case of the one that I just made up, it didn't. So that's why we had a hypothetical over there. But just in case, just like you would, you know, negative 4 plus minus the square root of something, you always try and simplify. Questions? Okay, you guys are doing good. We're almost done. All right, we're going to talk about square roots. Now, don't worry about this stuff here. It was a whole long solution, and I erased everything except for that one step. No big deal. You guys are going to have operations where you're breaking down radicals, whether they be real or imaginary. But you need to understand that when you break them down, you can combine stuff. Real stays with real, imaginary with imaginary. So think about the square root of negative 3 is negative 1 times 3, correct? Yes? Yep. What is the square root of negative 1? I. You can bring it out in front, and the root 3 stays there. You can break down 12. So negative 1 times 4 times 3. Breaking down radicals like normal, it's one extra step because there's an I in it. So what could I take out of negative 12? What's the square root of 4? 2. What's the square root of negative 1? So this would become 2i square root of 3. So now you can combine these. Could I add these two together? They're both imaginary, right? How do you know they're both imaginary? They have the i's, and they both have the same square root, right? So if I added these, it'd become what? 3i, root 3, okay? What about if I subtract? Could I subtract them? Sure. It would be negative I square root of 3, yeah? Could I combine them, adding or subtracting, whatever, if it looked like this?
No.
Why not? Good, because one is real, 2 root 3 is real, but I root 3 is imaginary. Do you guys see the difference there? Okay, so let's talk about if you had to multiply them together. All right, let's just say we were multiplying these two together. What's I times 2i? 2i squared, which would become what? Negative 2. You cross off this. This becomes negative 2. And then what happens when you multiply the square root of 3 times the square root of 3? You get just 3. So what would your answer be here? Negative 6. Right? As long as they're both real or both imaginary, you can treat them just like you would any other square root, any other operation. So if you look at B, all right, we would break these radicals down. You can break down 48, break down 27. The only thing that's different is this is imaginary. How do you know it's imaginary? Because there's a negative. So sometimes it's helpful, guys, to write the negative 1 so you realize, ooh, there's an I. And then break it down into a perfect square and a non-perfect square, 16 and 3. So what can you take out of this radical? 4i, right? Root 3 stays. Minus, what can we break down negative 27 to? Negative 1, 9 times 3, right? So it becomes what? 3i square root of 3. Now can I combine these? Yes, I can combine them for two reasons. One, they're both imaginary because they have i's in them, and they both have the same radical. So 4i root 3 minus 3i root 3 just gives me 1i root 3. You want to write the 1 in front? That's fine. Anybody with me? Okay, good job. Yes, I'll show you why. Go ahead. Well, you should end up with the same answer. What'd you pick? Okay, 12 and 4. Okay, that's fine. So you came out with 2i root 12, right? Now, is there a perfect square inside of 12? This is the same as 2i and then 4 times 3, right? Yeah. So what's the square root of 4? So you'd have to bring it out, and then you'd multiply these two together, so you'd get 4i root 3. Oh, okay. I just picked the bigger. Yep. All right, let's look at the last page. We're going to talk about complex solutions of a quadratic. Yep.
How come you had to do all that stuff for A? Like, why can't you just... Oh, it's just a different way. I was so lost. I don't know.
Read to me what it was again.
It was like for
oh, why'd I add them and subtract them?
Like we just added them. Like for B, like it was just 4i minus 3i.
Well, because I could have done addition, and then I was like, what if I subtracted them? What if I multiplied them? I just was making up problems as we went, just talking. I did more than one example, just walking through it, like because I showed you how to break it down, and then I was like, look, can we add them? Can we subtract them? That sort of thing.
Okay.
Yeah. All right, guys, what do you notice the difference is between A and B? They are different numbers, yes.
The amount of terms.
The amount of terms. A does not have a B term, right? B has a B term. So some of you made this mistake on your quizzes. You came out with like x squared equals 25 when you found your zeros, and you told me that x equals 5. Is that true? Yes. But there's two 5s. There's one that's positive and one that's negative. A lot of people forgot that plus minus. It's really important, guys, because that's two places on a graph, not just one. But when you are solving a quadratic, right, they're not going to always tell you that it's complex solutions. You need to know that. If this said x squared minus 4, what would my answer be? Plus or minus 2. This says x squared plus 4. If you guys go to solve this, x squared plus 4, if there is no b term, you can just solve it like normal. Move the 4 to the other side, becomes x squared equals negative 4. Then take the what? Take the square root. Remember, if you need to do this to help yourself remember, when you put the square root on, you need a plus or minus. And this is really negative 1 times 4. What is the square root of negative 4? Plus or minus 2i.
Oh, okay.
There is a huge difference, guys, with plus minus 2 and plus minus 2i. If you forget the i, you are totally changing that the solution is real or imaginary. So little stuff like that. I keep harping about keeping up on the little things. It makes a big difference. If you're given a quadratic and it doesn't tell you, God bless you, that it's a complex solution, the first thing you should try and do is factor it. You don't want to just jump to quadratic formula. But you have to be careful. If I try to factor this, I have 3 times 5 is 15. Are there factors of 15 that multiply to give me 15 but add to give me negative 2? Yes. I disagree. I can get negative 15, but I can't get a positive 1. So a lot of you would go, yep, 5 and 3, got it, negative 5, positive 3, I'm so smart, which a lot of you really are. But you have to pay attention. You need a positive number when you multiply. That means both factors have to be positive or both have to be negative. They can't be one of each. That's the only way you'd get a negative 2 is if they're one of each. So in this situation, you have to use the quadratic formula. When we use the quadratic, everything needs to be set equal to 0 On one side, so our signs are all correct, then you identify your A is 3, B is -2, and C is 5. You guys will have questions on your test that says solve using the quadratic formula. For those of us that do not remember, it's -b plus or minus b squared minus 4ac all over 2a. The hardest part of the quadratic formula is A, remembering it, and B, plugging all the numbers in where they should go. But if we go to plug these in, I have -2. I understand that that's a positive. I would just take a second to make sure all your signs are correct in your formula so you don't make any silly mistakes. But I have b squared, so -2 squared minus 4 times a is 3, c is 5, and divide that by 2 times 3, which is, we'll simplify that in a second, 2 times 3. So take your time, guys. A negative gives me a +2. Plus or minus. What is -2 squared? 4. Then I have minus 4 times 3 is 12 times 5 is 60 all over 2 times 3 is 6. Keep simplifying. Some of you like to go left to right. Some of you like to go up and down. Doesn't matter to me. I have 2 plus or minus. What is 4 minus 60? -56. As soon as I see that negative, I think, uh-oh, I should have an I in my answer. So I'm going to keep on simplifying. I have 2 plus or minus. I'm going to break down 56 into -1 times. Okay, 8 and 7, I do agree. But neither 8 nor 7 are perfect squares. But 8 has a perfect square in it. What is it? 4. What's 7 times 2? 14. So does 14 and 4 work? Yes, it does. If you did 8 and 7, okay, just saying you did. -1 times 8 times 7. That's totally fine. Then you got to break down 8. So it'd be -1 times 4 times 2 times 7. So the perfect square and the I you would take out would be right here, which would be 2i, and then you'd be left with 14. So if you look here, guys, what can I take out? Well, the square root of 4 is 2, and the square root of -1 is I, so this becomes 2i. So it's 2 plus or minus 2i root 14 over 6. Here's a big common mistake we make. You guys go, okay, this becomes a 1, this becomes a 3. There's my answer. Is that true? No. You have to look at these independently. This is 2 over 6 plus minus 2i root 14 over 6. You can simplify both of these. 2 over 6 becomes 1/3. And this becomes, right? You can leave it separated if you want. 1 over 3 plus minus I root 14 over 3. Or, since they both have the same denominator, you can put it back together. But remember, too, another simplification thing that we do, guys. 2 over 2, if you had that, like 2 over 2 plus 2i root 11 over 4. What would that reduce to? 2 over 2 does not go away. It becomes a what? 1, and this would be plus or minus. What does this become? I root 11 over 2. Do you see how the denominators are different? That's okay. That could possibly happen, but just make sure you guys look at each term independently. That denominator goes with both the 2 and the 2i root 14. That make sense? All right.